So this is GATE 2020 question number 16, which states that as shown in the figure, an ideal gas is confined to chamber A of an insulated container with vacuum in chamber B. When the plug in the wall separating the chambers A and B is removed, the gas, as expected, fills both the chambers. Now, which one of the following statements is true? So, if you just see the solution of this. So what is given is that an ideal gas is confined to chamber A here. Let me change the color. So here the ideal gas is confined, and this side it is vacuum. There is a porous plug which is generally separating the two walls, that is A and B, and this plug has to be removed, and the gas which is there, it will automatically come freely without any force or without any force given. So initially it might be having some pressure P, but when this wall is removed or this porous plug is removed, then this gas will freely expand. Therefore, since this is an example of a free expansion, or it is also known as the Joule's free expansion, the process is Joule's free expansion. Now, since there is no restriction here on the gas, it is freely expanding, the work done or the change in work done is zero here. This is the process, the way the process is defined here. Here the dW, the change in work done, is zero. On the other hand, the device is also thermally insulated as given in the question. So therefore dQ will also be zero. Now according to the first law of thermodynamics, dQ will be equal to du plus dW, which conserves the energy. Now dQ is zero, dW is also zero. dQ is zero, why? Because the device is thermally insulated. dW is zero because it's a free expansion. We are not providing any force in this particular container, neither do the gas expands here and doing certain work. So therefore the du is zero, the change in internal energy is zero. Therefore internal energy final will be equal to internal energy initial. Therefore U will be, as we know that this internal energy, so we know that internal energy which is nothing but the internal kinetic energy, is function of temperature only. So we have seen that in your kinetic theory of gases. From kinetic theory of gases, it comes out that the kinetic energy is about 3/2 kBT. So it only depends on the temperature. So U is a function of temperature. Now since U is constant here, we can clearly mention that temperature also remains constant. So A is the correct option. So this is a free expansion question, that there is an ideal gas initially at A, and at B it is vacuum. Now slowly this wall separating these two gases, these two parts A and B, is taken up, and the gas freely expands over the entire device, and the device is thermally insulated, which is given in the question, and hence we have got that due to the free expansion there is no work done, change in work done is zero, change in heat is also zero because it is thermally insulated. Therefore du, the internal energy change, is also zero, or internal energy is constant, and internal energy being the function of temperature itself or only, so internal energy remains constant means temperature of the gas remains unchanged. So this is the correct option. Temperature of the gas will remain unchanged, and this process is also known as the Joule's free expansion. Joule's free expansion. Therefore, in this case, the temperature of the gas remains unchanged. Should be the correct option. Thank you.